How exactly do you resurrect a globally extinct asset when your entire working capital is reduced to 7 units? Not 7,000. 7. Total. On the entire planet. That is the single question we have to unravel today. In 1981, that was the brutal mathematical reality for the Crested Ibis. When we think about saving a species that has fallen into the single digits, we assume the answer requires high-tech laboratories. We assume it demands blank check government funding. We have been conditioned to believe that conservation is a story of human dominance. We swoop in with advanced science to correct a mathematical error. But is that how nature repairs itself? Or is the truth something much quieter and much more complicated? To understand how impossible this recovery is, you first have to understand the depth of the collapse. At the turn of the 20th century, the Crested Ibis was everywhere. The scientific name is Nipponia nippon. That translates directly to the Japan bird of Japan. It formed massive, loose breeding colonies across a vast arc of East Asia. They stretched from the Russian Far East through the Korean peninsula. They flew across China and throughout the Japanese islands. The skies were completely full of them. But by 1981, Japan had just captured its last 5 wild individuals. They placed them in cages because they were failing to reproduce in the wild. Scientists across the globe had already written the obituary. The consensus was a flat 0. The species was considered functionally extinct in the wild. So what happened? How did we get from a dead species to a thriving global population? The answer starts with a 3-year search that yielded absolutely nothing. Chinese scientists walked over 50,000 kilometers across historical habitats. They found empty skies, empty wetlands, and empty rice paddies. The search was entirely hopeless. Then came May 23, 1981. A Chinese ornithologist named Lu Yinxing was walking through a remote, anonymous valley. The area was called Yaojiagu, buried in the Qinling Mountains of Shaanxi province. He was not looking for a miracle. He was there to conduct a survey that would officially confirm the absence of the bird. He was there to close the book. But instead, he looked up at a pine tree on a hillside. No survey team had ever bothered to check this specific ridge. Sitting in the branches were 2 adult pairs and 3 fledglings. 7 birds. The adults had white plumage with faintly pink wingtips. They had long, red-tipped bills curving down toward the dirt. A crest of white feathers extended behind their heads. These 7 birds were all that was left anywhere on Earth. A report was immediately sent to Beijing. The news reached Japan a few weeks later. Researchers at the Crested Ibis Conservation Center in Tokyo received the message like a transmission from another planet. They had spent years mourning a species they believed was already gone. Now, 7 birds were alive in a valley nobody had checked. They were just waiting to be found. This immediately forces a massive question. Out of all the vast, resource-rich wetlands across the entire East Asian continent, why did the absolute last survivors hold out on this one specific, unmapped hillside? To answer that, we have to ask what erased them everywhere else. The Crested Ibis is a highly specialized wading bird. That long, curved bill is not for spearing fish in deep water. It is for probing. The bird wades into shallow mud and feels around for prey. It hunts frogs, small fish, crayfish, and earthworms. Cannot hunt in deep lakes. Cannot hunt in dry fields. For thousands of years, traditional rice paddies provided the perfect artificial wetlands for these birds. Human agriculture actually expanded their hunting grounds. The birds and the farmers operated in perfect synchronization. Then the 20th century arrived all at once. We prioritized massive agricultural modernization. Farmers drained the shallow wetlands to create dry, highly productive fields. Deforestation removed the tall pine trees the birds needed for nesting. But here is the problem. The biggest blow was completely invisible. We introduced heavy chemical pesticides across the entire agricultural sector. When you spray a rice paddy with organochlorines, you kill the frogs. When you kill the frogs and the invertebrates, you completely bankrupt the food chain. A bird that probes shallow water for living prey cannot survive in a chemically sterilized field. The system collapses. The poison moved up the food chain. The birds ingested the toxic chemicals through their prey. Their eggshells thinned. Their chicks died. The population crashed. It was a textbook ecological market crash. By the 1930s, the bird vanished from Russia and Korea. By the 1950s, it was gone from most of Japan. By the 1960s, Chinese zoologists gave up looking. The economic engine of the modern world simply outpaced their biology. So why did that one valley in Shaanxi survive? Why didn't the crash happen there? This is where the investigation gets incredibly strange. The valley survived exactly because it was left behind. It was too remote, too inaccessible, and deeply poor. The local farmers simply could not afford the modern chemical fertilizers and pesticides. The chemicals destroying the food chain everywhere else never reached Yeojiagu. The poverty of that specific valley meant the rice paddies remained flooded in the winter. The frogs and fish survived. The trees remained unlogged because timber trucks could not reach the ridges. The very thing we normally view as a massive societal disadvantage became a shield. A complete lack of economic development preserved the greatest biological asset in the region. But finding 7 birds does not save a species. It just delays the inevitable. The hardest part was just beginning. A population viability analysis published in 1998 ran the numbers on this exact flock. The data showed a grim reality. Without massive, successful intervention, the birds faced a nearly 20% probability of complete extinction within a century. The researchers were operating without a safety net. There was no backup population. If a single storm hit that valley, the species was gone. If a predator found that pine tree, the story was over. The margin for error was absolute zero. This puts you in an impossible position. How do you manage a resource this fragile? If you were handed a failing, priceless asset with only 7 units left on Earth, what would you do? Would you trap them all in a vault to protect them? Or would you risk leaving them exposed in the wild to figure it out? Let me know what you would choose in the comments. The researchers in China had to make that exact call. Their decision changed everything. They decided to leave the adults in the wild. Trapping them would have destroyed the only functioning breeding population on the planet. Instead, they launched an extreme security operation. Pesticide use in the surrounding rice paddies was banned overnight. They guarded the nest trees around the clock. Volunteers camped under the pines. They chased away snakes and weasels. They supplemented food in the paddies when the birds struggled to find enough calories. It was a massive manual effort to tip the scales. When a nest had multiple eggs, they carefully removed the spares. They incubated the extra eggs artificially. They raised a parallel captive population while letting the wild adults do what they knew how to do. It was careful, agonizing work. Every move required intense calculation. The crested ibis is extremely sensitive to disturbance. If you approach a nest too closely during breeding season, the pair will panic. They will abandon the nest entirely. They will leave eggs and chicks to die mid-incubation. Researchers had to adapt instantly. They learned to use binoculars from distant ridgelines. They timed their nest checks to the brief windows when adults were away foraging. Every breeding attempt was documented. Every failure was analyzed. The pressure was unimaginable. The first years were completely terrifying. In 1981, the wild population was 7. In 1982, it was still exactly 7. Breeding occurred, but survival of the chicks was highly uncertain. Every storm felt like the end. Every failed nest felt like a permanent tipping point. But here is the thing. Protecting the bird is useless if you don't protect the environment that feeds the bird. When researchers began mapping the bird's movements, they found something critical. The birds were entirely dependent on the farmers. The ibis territories were heavily centered on traditional paddy fields. Their breeding success was directly tied to the availability of winter-flooded rice. Fields converted to modern intensive agriculture produced almost no food. This meant saving the crested ibis was not just about guarding a bird. It was about protecting a specific way of farming. But how do you convince hundreds of local farmers to willingly reject modern, highly profitable farming techniques? You cannot ask people to starve for the sake of conservation. You have to change the math. The conservation program realized they had to flip the economic incentive structure of the entire region. They had to build a new economy. They began paying direct subsidies to the farmers. They paid them to keep the paddies flooded in the winter. They strictly forbade the use of chemical pesticides. But subsidies are just a temporary crutch. To make it permanent, they turned the Crested Ibis into a premium brand. They helped the farmers achieve organic certification for their crops. By the 2000s, Yongxian County organic rice was a massive success. Marketed with the Crested Ibis logo, it was selling at a premium. The higher price per pound completely compensated the farmers for the lower yields. The conservation subsidies had turned into a self-sustaining market. They performed a brilliant economic arbitrage. The birds desperately needed the farmers to maintain the shallow water. But now, the farmers needed the birds to justify the premium price of their rice. The wildlife and the local economy became completely codependent. Perfect feedback loop. So the economics are fixed, the habitats are secure, and the birds begin to multiply. By the year 2000, the population crossed 200 individuals. By 2005, the wild population alone passed 500. The original 7 had become a true population. Birds were moving into adjacent terrain and breeding on their own. New nesting sites appeared outside the original valley. It sounds like a perfect resolution, right? But doesn't this entirely ignore the biological elephant in the room? How do you build a healthy, functioning population of thousands from a genetic foundation of just 7 individuals? The math does not make sense. Every single Crested Ibis alive today descends from those 2 adult pairs in that pine tree. That is an extreme, terrifying genetic bottleneck. We know what happens when gene pools shrink that tight. A 2014 study published in Genome Biology sequenced the DNA of the recovering population. The results revealed a brutal truth. The species had lost almost half of its ancestral genetic variation. A follow-up 2019 study in Current Biology confirmed the damage. They carry a massive load of deleterious mutations. Their genetic code is fractured. Biologically speaking, they should be extremely fragile. They should be sickly, collapsing from inbreeding depression, and highly vulnerable to disease. Yet they are thriving. The birds are surviving despite a ruined genetic foundation. Why? Because the environment they live in has been perfectly engineered to support them. The restored rice paddies offer an immense abundance of high-quality food. The conservationists removed so many external stressors that the genetic flaws are masked. The birds don't have to fight for survival, so their broken genetics never get fully tested. This might work for you as a way to think about resilience. A supportive environment can override a flawed biological foundation. If that makes you rethink how survival actually works, hit the like button. It is a profound realization. We spend so much time worrying about the internal genetics of a species, but this proves something incredibly powerful. Fix the external environment, and life will find a way to endure its own broken code. And because they endured, the population grew massive. China eventually had to start exporting the asset. Remember Japan? The country that gave the bird its scientific name had lost its entire original population. The Japanese revered the bird. Its feathers were historically used in samurai arrows, and its exact shade of pink was called Tokiiro. But reverence did not save them. The last Japanese-born wild ibis died in captivity in 2003. As a gesture of massive diplomatic goodwill, China began donating pairs of captive-bred birds. They handed them over to Japan to restart their breeding engine. But Japan faced the exact same problem China had solved decades earlier. You cannot release a waiting bird into a sterilized, modern agricultural zone. Sado Island was the species' last stronghold in Japan, but it had been intensively modernized through the post-war decades. The shallow, fish-filled paddies had been replaced with highly productive, ecologically sterile fields. Before Japan could release a single bird, they had to reverse engineer their own agricultural sector. It took almost a decade to set up. They had to negotiate with hundreds of individual farmers. They established massive subsidy programs. They developed a certification system for traditional Sado rice to match the Chinese model. They had to build community buy-in across an island where most residents had never even seen a wild ibis. In September 2008, the moment finally arrived. 10 captive-bred crested ibises were released into the wild skies of Sado Island. The ceremony drew national television coverage. The release had been 27 years in the making. The early releases did not go cleanly. Some birds moved immediately away from the prepared habitat. They traveled to parts of the island where the paddy restoration hadn't happened yet. Some did not survive their first winter. The transition from captive feeding to wild foraging is a difficult skill. Not all birds develop it fast enough. But the researchers adjusted their strategies. They moved release timing to the spring. This gave the birds the full productive season to learn how to hunt. They selected individuals with stronger wild behaviors. Slowly, the system started to work. In 2012, the first wild-born crested ibis chick hatched in Japan in over 30 years. It was not hand-raised. It was wild. It was born to parents that had themselves been born in captivity. It was learning to forage in a region that hundreds of farmers and volunteers had spent years preparing. Today, the numbers are so extreme they barely feel real. Data from recent years confirms the global population has crossed 7,000 individuals. State media reports even suggest the total could be closer to 11,000 when factoring in new releases. In China's Hanzhong city alone, thousands of birds fly completely wild. They dominate an expanding habitat that now covers thousands of square kilometers. China has a massive, self-sustaining wild population. Japan has wild-born chicks thriving on Sado Island. South Korea has launched its own highly successful reintroduction programs. 7 birds became 7,000. It is arguably the greatest return on investment in the history of ecological preservation. But sitting with this story forces us to arrive at a much deeper, more unsettling question. What does this mean for the concept of extinction itself? None of this exists without a footpath in a Shaanxi Valley in May 1981. None of this exists without 2 pairs of birds that stubbornly stayed in the one place nobody thought to look. None of this exists without Lu Yinxing. He decided to walk 1 more kilometer into a valley that wasn't even on his list. He was running a survey specifically designed to confirm the species was extinct. But he looked up at the exact right moment. If he had turned around, the story would be over. If a storm had blown through that valley a week earlier, the species would be gone. The margin between complete erasure and a flourishing global population of 7,000 was just one man looking up at a pine tree. So if the line between extinction and resurrection is that incredibly thin, what does that mean for everything else? What other quiet miracles are hiding in the valleys we simply forgot to check? What other broken systems are holding on by a thread? They are just waiting for someone to change the economic math and give them a chance to rebound. The world is full of these hidden comebacks. If this changed how you see the crested ibis or what a healthy wild ecosystem actually looks like, let me know in the comments. And subscribe because there are more of these comeback stories than you'd ever guess. Im Edmund Hale. Thanks for watching.